So here we are in Module 1 still, and we're in our Section 3, and we're comparing real numbers. So remember, our real number system are numbers that we can count, we can estimate, we can measure, we can use for practical real-world situations. So we've got two types of numbers in our real number system. We've got rational numbers and irrational numbers. Remember, rational numbers are numbers that can be written as a fraction or a ratio. So these are going to be things like repeating decimals. They're going to be your whole numbers, your integers, your counting numbers. A lot of stuff we use every day. Then we've got these irrational numbers, and these are not crazy numbers. These are just numbers that we know are going to go on forever. They're never going to end. They're never going to repeat. Okay, so probably think of like your most boring subject. Yeah, they're irrational numbers. So things like the square root of 3, it's going to go on forever. We really, in our real world, don't care about a lot of the decimal places after the first two. So we will round it. So you'll hear the term irrational, but well-rounded. Pi is a great example because, again, it's going to go on forever. In 95% of things we do in this world, 3.14 is going to be satisfactory. There may be some instances or circumstances where you may want an additional decimal or two of pi, but again, for real world situations, you're not going to use all of the irrational number because you're going to be here for the rest of your life. So just kind of think about that as they start talking about irrational numbers. And just remember, rational numbers are going to be numbers that you can round um, if they repeat or they're going to end. Okay, irrational numbers, you pretty much have to round them because they're never going to end. And so there's kind of our number system that we're dealing with here. So let's look some of questions that they could ask you about rational and irrational numbers. So this one here real quick is just going to say, well, which number contains both rational and irrational numbers? So as we start to pick apart our number sets here, we've got a fraction. So that's the definition of rational right there. You've got 3. You've got the square root of 4, which is a whole number of 2, so that's going to be rational, and 2.1. So all of these numbers here are going to be rational. So that's not going to be our answer. So we look at B. You've got the square root of negative 4, negative square root of 4. So that's going to be a negative 2. So again, that is a rational number. Negative 1 is a rational number, and 4 and 7 are obviously rational numbers as well. So again, all rational numbers there. We're not going to worry about that too much. So if we look at C, we've got a decimal that ends or terminates, rational. We have a repeating decimal, rational. 1.35, a terminating decimal, and then this is 1.121212. They don't tell us it repeats, so so in this case, I'm assuming it's going to end or terminate, but it's still a rational number. So all three of these instances contain rational numbers. So if we look at D, we've got the square root of 4 is a rational number. The square root of 4 is 2. So that is our rational number. And then the square root of 3 and 5 are our irrational numbers. So here in our next sample, we've got a set of numbers, irrational and rational numbers, and we're asked to arrange them or order them from greatest to least. Okay, so that's the first thing, greatest to least. So you want to find the biggest one. So as our hints kind of tell us, figure out or estimate a decimal value for all of your answers. And that's the easiest way to put them in order. So 26 fifths is 5.2. It's actually 5 and 1/5. 1/5 is the decimal point 2. So I know that's exact. Then we've got the square root of 26, which is just slightly over the square root of 25. So I estimated that to be 5.1. Then we've got 5.8. Again, we don't need to worry about that. And then the square root of 35 is super close to the square root of 36, which is 6. So again, I just kick it a little bit less than 6, and I estimate it to be 5.9. So by my estimation skills, I need the square root of 35 first. That's my largest value. Okay, and B is our only example with the square root of 35 being the largest value. And then just to kind of check, we should see 5.8 and then 26 fifths and then the square root of 26 as our order. So in looking at simplifying square roots a little bit, you want to pull out any perfect squares out of your radicand. So in this case, if you look at the square root of 135, that is the square root of 9 times 15, okay? So since 9 is a perfect square, what's the square root of 9? That's going to be 3, and we are left with 3 times 15. So obviously the Keystone exam is going to ask you a little bit more challenging questions than that. So we actually have to think about what was the problem. So the question asks us for the value of x. And there are a couple of different ways to solve something like this. And if you're kind of stuck, just plug in all of your answers and then go from there. Okay. So I noticed that we went from 2 to a 10, right? Which tells me that I had to pull out a factor of what? I had to pull out a factor of 5, okay, from inside the radicand. So what number is going to give me a factor of 5 coming out of that radicand? And that number is going to be 25. When I take the square root of 25, that gives me 5. And so by looking at the problem, and seeing what has transpired, you can then kind of work backwards from it. Again, if all else fails, you've got a calculator. Take and just start guessing and checking a little bit with your answers, and hopefully you can figure out that you're pulling out the 5. Now the question asked for what is the value of x as well. And remember, x is inside the radical here. So that would have to be a 25 in order to come out as a factor of 5. So just kind of keep that in mind as you're working through the problems. So as you're working with roots other than 2, okay, your calculator does have a button. It's the number 5 button in the math menu. You can do that. Again, however, you don't necessarily need to know all of those fancy buttons and that. You can always work backwards and guess and check. So in this case, if you think about what is the value of the fourth root of 1,296? What does that mean? So what number times itself 4 times gives you 1,296? So as long as you understand what a fourth root is, you can then work backwards a little bit and just say, okay, so what's 6 times 6 times 6 times 6 in my calculator? Or what's 7 times 7 times 7 times 7? Or what's 8 times 8 times 8 times 8? Or 9 times 9 times 9 times 9? So again, if you just plug in your 4 answers, work backwards a little bit, see which one to the 4th power gives you that 126 or 1296, you should be in great shape. All right, so a couple of things. Don't forget your terminology. So greatest common factor or least common multiple. Just remember, greatest common factor is the biggest number you can divide out of both numbers. And with the least common multiple, you're skip counting along the way. So as you start to skip count your numbers or your monomials, you want to find that common one, the least common one. So you just don't want to overshoot your kind of your projections there with that. So as we move on to exponents and roots and more absolute values, a couple of highlights that I wanna bring to your attention. A negative exponent. Remember, negative exponents are never, ever, ever, ever negative numbers. They mean the reciprocal of your cubed number from there. So it's something like 4/3 to the negative third. What that means is the reciprocal of 4/3 times 4/3 times 4/3. So you're actually going to flip those over and you're going to have 3/4 times 3/4 times 3/4. Something like 8 to the negative 2, it's going to be, again, the reciprocal, so it's 1/8 squared, or 1/8 times 1/8, which is going to give you 1/64 in the end. And then here's your properties of exponents, and I'm sure you've seen all of this already. So just kind of understand when you're adding and subtracting your exponents. But I think the biggest advice I can give you is when in doubt, write it out. Look and think about what it means. Break it down and kind of start crossing things out. If you forget about your that when you are dividing the same base with different powers, you subtract. Just again, start canceling it out. How many x's do I have in my numerator versus how many I have in the denominator? How many more do I have in one or the other? That's going to kind of give you an idea. So again, when in doubt, write it out. Use your instincts. You've got good instincts. You've made it this far in Algebra 1. You can do it, okay? So here we've got 2 sample questions, and again, all of these scanned answers are in the slideshow as well, and I just kind of have some talking points with the video here. So if we look at our last, then we're talking about absolute value. And again, absolute value is the distance from 0. So again, you kind of work within the absolute value, just like you would parentheses, and whittle it all down to a value that you can then take the absolute value of. And again, which is just pretty much taking the negative sign away. So again, some terminology. Don't get bogged down with the terminology. If you forgot one of the vocabulary words, let instincts take over. You can really just kind of figure it out without some of the terminology sometimes. And often students get bogged down with the terminology and forget their instincts. So just kind of start doing what you've been trained to do all year, okay? So things like monomial, binomial, and trinomial, they're just names for polynomials. A monomial is a one-term polynomial. A think about that, two-term polynomial. A trinomial is a three-term polynomial. So just kind of don't get scared because they're trying to use some big words. All right, you've got this. So with adding and subtracting polynomials, just make sure you're only combining like terms. They're going to try and trick you with questions like when you have this negative out here. Remember, you've got to distribute that negative to all pieces of your following parentheses as you're simplifying those and combining like terms. And then when you're multiplying something like this, and this is a pretty typical standard kind of polynomial expression that you want to give, you really have to start to think about what's happening and what's kind of going on. And I notice in particular right here. So here's my result when they do all of this multiplication and subtraction. So as I start to look, I've got this minus 8 to the 5th here. And I know that when I multiply this 2x squared and this whatever this number is, x to the 3rd, I'm going to get an x to the 8th power, or 5th power. And so in order for this and this to cancel out, that's going to have to be a 4. 4 times 2 is going to give me 8x to the 5th here, and that's subtracted out. So that's kind of a quick like look at what's going on, and pay attention to really what's important and what's different as you're kind of working through some of these. Okay, and as we wrap up Module 1, I just want you to look at these 2 sample questions here, and both of these are asking you to factor things. They're not going to give you a lot of wild and crazy factoring problems. And again, I've said your answers to help give you and guide you if you're kind of stuck on something. So like over here, we're trying to factor this, and so you have to think of like factors of 36 that have a sum of negative 13. And sometimes we don't necessarily think about like 9 and 4. You might be thinking of 12 and 3. So use your answers, your multiple choice answer to kind of guide you as you're working through this, okay? Trust me, one of the answers is correct as you work on this. All right, that wraps it up for Module 1 for us. So great job. Thanks for listening. And please don't hesitate to email me if you have any questions on anything.